Okay, so we got our 9 a.m. people here. We have 4 out of our 10 a.m. people. And 5 out of 7. 10 a.m. I play Michael.
Definitely Michael.
Huh?
Why your group's over here?
No, we got.
You have 4 people from your section. And I blame you.
What? I blame Roy. Like, ever since he left, no one's I can't be here without Roy. They're done. Roy's fault.
Armin probably sleeps until 1 o'clock again.
Did you like turn into a trip on purpose?
On purpose.
That's a me.
Do what? He's usually relatively on time.
Just him. I think that's weird.
Ron is not in the 11 o'clock, he's in the 10 o'clock.
In the sea.
The sea of people.
What?
You're hiding.
That's it.
You guys are so cute. You
Oh.
Simone.
Oh yeah. She texted about this morning. Never mind.
Did you really?
Yeah.
Oh, wow.
I was like, I'm just going to trying to get this text. Like, nope, not today. It says a different day.
Trying to see Nicholas, so he saw us looking very conversation with different
Yes.
Oh,
it's just that it's
So I just picked that one and
why is my car
I didn't know we were supposed to do it until right now.
I sent the email out
Yeah, all it
yesterday.
is is explains all the polarity. And,
It doesn't, I mean,
hey,
jump ship.
Tim.
It's him.
Tim.
What is his name?
Armin.
Armin.
Oh, I know. We woke up to proctor exams for mentor program. April 1 in the summer. And then, yeah.
What?
The mentor program.
Oh, yeah.
Woo!
Okay, guys, so we're gonna go ahead and get started. I went ahead and just printed out, the slides for you guys. So I just have one for each group today. So if you guys wanna go ahead and go into your groups, and go over the slides. A lot of the beginning of the slides are a continuation from what we did on Monday's lecture. So go ahead and review those a little bit, in your groups, and then we'll go over it, as a class to make sure everybody's ready, for that in class. Okay, so go ahead and get into groups.
No, you heard me. You want me to
Let's just.
Aging's right here, and I wasn't there. You should come to us.
It's alright. I don't know the world clock.
Thomas? Chilling? I guess we could try tearing through the slide. To be honest, we'd already have them. So, the first question, number 1, apparently is a training for everybody. So,
You get one slide per group. We still.
I think we stopped like in 3 minutes.
Unless you're adding an odd number, it's only supposed to get an odd.
It's that same whole question again. What do you guys still think?
Structure,
Thinking about it in class. You should have this first too.
Side of every class.
Well, she
So now it's the questions are diamagnetic.
diamagnetic. Yeah. Most molecules. Yeah, I agree because they're paired. Is that what you guys said?
Yeah, that's why I feel it's dia plus they're all even. I feel like they're all paired.
Yeah, that's what we chose last
Cool.
time.
Cool. I just want to make sure like we're all the same boat there. Before we go to class, I'm like,
Okay.
When you're like living in your orbital, you want one.
typically it should be stuff.
So what's the
Right?
Alright.
Yeah, no, that's what I always think. That's why my mind is always.
But that needs to be.
Yeah, that's basically what it is. Like that needs to be like that
Intramolecular.
for the question, so it's fine. I can't read it upside down, so this is the picture page.
So intramolecular is like bonds, right? And then intermolecular is like hydrogen bonds.
I think it's just a slideshow.
Yeah.
But they are like.
Ooh, this is one.
A lot of it's IMF stuff.
Yeah.
Right, that's intra.
For water, what's the strongest
Like, yeah, like this one's like all overlapping. This is, I don't know what that was. This is a thing going on. So, okay, so they talked about. Halfway through in one of the Iverson students was like, it's the
This is your hydrogen.
So learn
Gas.
to gas to or make more gas out of
Atom bond.
No, significant one, two, ethanol. Yeah, overlapping. Here's like actually it's just kind of evenly spread out. Blob shapes. Oh, now we start.
Here, okay. All non-polar compounds.
Yeah.
Let's show you. All non-polar compounds are gases.
I feel electricity. I think we all got it. But it's this one's very simple as well. Very, very simple. It's a very simple idea is that they have mostly point of view. They have point of view. The idea process is pretty simple.
Oh, water and ethanol. Oh. That has nothing to do with this.
And then you discuss why it's structured and effects you have. So LDF is the interaction between
Yeah, because they have van der Waals.
so these two LDF. The intramolecular is the big thing because that's where the big difference is. Especially hydrogen bonds is what people get confused on.
Yeah, like we were saying.
So inter
Why
is gonna be
is carbon tetrachloride
molecules
all the
around
bigger?
it, intra is on the same.
Hydrocarbon.
So
able to equilibrate with their expanded. I guess that's what she's gonna go into.
Reactor, oxide, water, molecule.
I guess maybe like a way that like maybe this
Because right here, like, and then we'll come up with some kind of combination and yeah,
Why can't the water Oh, okay.
There's actually more than 4.
Yeah, I want to see that down as basically all of it.
that's
But I don't-
and it explains it. Yeah, it's just.
Stock
it's
question.
That was all
the
that.
recipe and electrostatic interaction.
Four lines are stronger than electric forces.
So it's,
Cool. So I guess we'll move on to this. Is there any fluid structure that y'all don't think you could draw? Given it's methane.
Why can't this
Yeah, we are doing it.
Methane, iodine, glycol, carbon tet.
Oh,
right.
There we go.
we can go over it though.
you guys think
I
about
was gonna say, I assume every in the past.
Oh,
On that surface, when you go to a question like this, you say,
Oh, and then
to this gas.
For the molecular waste boiling point.
Okay, yeah, definitely. More than
All she did
anything.
was really, she finished the video from both of you, which was, you know what I'm saying? And she talked about that. She introduced me to integral forces, and I changed the name. It's not difficult. So I think
Less space.
she talked about
Correlation between OH bonds and boiling.
Like,
Oh, yeah, look, this was solid.
Yeah, and you can remember that, or, sorry, practice
Solid.
between around.
Why is that no more quantitative?
So like between.
What are these pieces?
And you can remember that because inter, they both have INT, right?
Okay,
So similar to forces.
Yeah.
Here's the idea behind it.
There it is.
So it's
Beautiful.
a compound.
I'm not sure what
They should.
Yeah, it's like,
The fact
it's like the same, it's like the same kind of like size, it's like the same.
Yeah, I think you're right. Base is still
All
an
atoms should
atom.
have
That's
Is that right?
all there is on it. It's like.
I don't know, but it's like asking the same thing.
You're making it
Really? You can really
Attraction of
Also, because it's like also number 3. It's like
Y-axis,
asking like that.
x-axis,
Does that make sense?
grab
I think it's weird.
Beautiful. This
Bigger
is
the
just
molecules,
hilarious.
the higher the
Because
Like, oh, are you talking about like
It's like,
yeah, what is the trend?
Once you get that, it's lots of which one.
From now on, for this type of mod, that will at the moment.
You go from selenium to germanium.
So, I didn't really understand this.
Okay, so the way I saw it, like the trend in the period, it increases as you go from left to right, except when you have like something like to make 2 bonds, like water, it's like H2O. That's just has a larger boiling point, and same with like the other periods, like H2O.
Bromine,
All non-important
Yeah, I guess.
exception. That's okay, what is the trend?
The trends within a group, that's like the line.
Shards.
So,
Is there hydrogen?
huh?
yeah, it's not.
Yeah,
That's what it is.
like that's.
I only can think that maybe someone's thinking true, like without even thinking honestly. Is because
Oh, and then
because
it increases.
A non-form molecule.
It increases top to bottom, it increases.
So first diatomic should actually
I know it's-
H2 and CO2 and all that. So then go through that kind of system.
Or up and down.
Yeah.
Oh, so what you're talking about, like.
Increases, you go top to
No, we're
bottom,
good.
obviously with all of your second period elements being accepted. Just because they only have one big to show.
Okay, so she,
We're not. It's March. Intellect forces.
and then she just talked about how there's
Period 2 is going to.
I don't know the difference between like element force and special force.
she, okay, so when she introduced them, she said.
Yeah, they're all the same. Oh, okay.
They're just
Why do we have so many names for those?
Well, like, it was iconic, right?
I like Van der Waals less. This is the one I use.
But like, that's all she said about it.
Alright, so this is.
Oh, okay. She also talked about
Why is H
Wants to stay as it's attractive force and everything.
And then it goes down
Fixing
for
carbon,
HCl.
This is liquid.
Ammonia.
And then it goes back up from CL. Anyone want to explain
This molecule overall is just pretty
Wow.
beautiful.
So I think it's
Well,
like
6 carbons, 14
oh, you're right.
She hasn't mentioned ODFs.
Sulfur is separate bonding. Oh, no, F, N, and O is hydrogen bonding. Oh, you're so right, yeah. So H after hydrogen bonding. So therefore, it's one point huge.
I always, she
So
always.
CL is one point. So it goes down. But then it increases.
So I want to say these terms and start thinking about, then she lied. Yeah.
Oh, okay.
How's possible?
So I was thinking in terms of
Okay, so the same
electric.
thing. It wants to put attraction.
That's not right.
Pneumatic forces. Dipole.
Oh, in the periods, it's.
So this idea is
So that was highlighted in a row.
Oh, and
That's the same thing.
It should be.
Maybe that's the slide.
But in
One of
here,
our-
Looks like the electron.
Irrelevant. So what's your
more IMS,
Yeah, so they were
sulfur, phosphorus, silicone,
boiling point increases as you go.
flexibility.
I think
Well,
the
that's
periodic
really
table
effective
goes
to
like
take away
left to
electrons.
right, except for
Yeah, I don't
So what's
Yeah.
up? Why is that? It seems to obey a trend.
What's the pH?
This is for Friday, so this is all. Yeah, this is good. These are Friday.
And then H2S.
That might be today's.
It kind
Only
of,
because
that's
they talk
kind of weird,
about
because it went from P to C.
This was also.
It does.
Yeah, we need to. They think they're both.
Yeah.
Yeah.
Yeah. Okay, so.
New favorite.
Yes, I saw that one first. I think so. I mean, it's this one. I don't know if it's that one.
As you go right to left, one right is correct. You never know where.
Oh.
Solid.
P R.
You don't have right to left.
Didn't they have one last week?
Yeah.
I feel like they just.
Yeah, but it's
Or you can all your helmets disobey that. If you notice the second from the top trend line is all
But this
your
is a what?
We're not doing it today, we're doing it on
so
Friday. We're gonna
we can
go
just look at it
over
real quick.
today
It's
and
And then
pretty
it's
simple.
like like F and CL.
Yeah,
So how's
so.
everybody doing? Is everybody pretty much wrapped up with, slides? Yes, okay. So let's go ahead and start, going over those as a group.
This stuff's pretty easy.
Okay, so we're finishing up our talks about our molecular orbital theory, and we're gonna start moving on to kind of the, liquids and solids and gases and kind of the end sort. So we'll be doing gases as heavily since we did gases a lot in Unit 1, but we'll definitely be focusing the end of Unit 3 on liquids and solids and here how they're interacting. Okay, so what do we think on this question? Do we think most molecules have an even number, an odd number, or equal chances of even and odd? And remember, this is not elements, this is specifically asking for molecules.
Even.
Even, okay, why are we saying, somebody wanna say why we're saying even?
The number of electrons want to be paired.
Do what?
The number of electrons want to be paired.
Right. And what also, if they're not paired and we have an odd number of electrons, what are we gonna see on there?
Charge.
We're gonna see a charge on there. Do what?
Radicals.
We're gonna see radicals and stuff. And obviously, especially for what we're dealing with just this material, we're not gonna be dealing with radicals, and we typically wanna have substances that are gonna be non-charged on there, right? We're typically wanna kind of avoid the charges unless we're trying to get something to react with it. Okay. So are most molecules diamagnetic, paramagnetic, or evenly split between the two? Diamagnetic. Okay, so there is actually a chart. So there's actually a chart online, and it actually lists whether something, and these are not for molecules specifically, these are just for individual elements on there, but it lists whether they're gonna be diamagnetic or paramagnetic. We can kind of see overall, we tend to see more diamagnetic elements overall. Not something we're going over in this class. Don't worry.
I'll be your first that openly. So that's a new turn.
Okay. So, and then we talk about this one and talking about calculating the lowest energy geometry and where's the electron density, which for most of you guys that are inorganic, that's obviously the biggest thing in that class is where are the electrons. Obviously you're gonna have your electron density in that. And so we can kind of, I'm assuming she's gonna go over all the kind of the diagrams with them, and a lot of them have not seen diagrams like this. Most of us are very familiar with those types of diagrams, but this is something new to them, and a lot of them probably haven't seen it very, very often. So we'll be going over that with them. Then we'll be continuing about going over our sigma bonds and our pi bonds and how they're overlapping And this is kind of going back a little bit to the valence bond structures, but this is trying to correlate how we're using the valence bond structures and how we're combining it with our molecular orbital theory on there. Okay, how's everybody feeling so far? Good. Okay. So for molecular orbitals, when we're dealing with the pi bonds, we're asking this whole entire concept of, okay, well, where are the electrons? And then we have this whole entire concept of they're actually being delocalized. Because when you're dealing with benzene, you're going to have a free pi ring available. So therefore, we're going to end up seeing kind of the two donut shapes on there. So typically, that's why we're seeing our benzene, right, drawn like this, right? Because we're indicating that this is going to be delocalized and going to be sharing across all available carbons on there and not just one specific one. Okay? Okay, going over more of this. And so this is just continue this whole entire idea that we're getting into these electron densities and not just our nice little ball and stick formulas, because those are really nice to look at, but they don't really give us a general idea about where everything can be located on the molecule. Or once we start looking at our picture furthest to the right, then we can start seeing kind of where these electron densities are actually being contained at. Okay, so then we're kind of starting to move on to our physical properties that we're going to be dealing with. And so we're talking about our intramolecular forces. So those are the ones that are holding together our different molecules, right? So the bond between the oxygen and hydrogen and water is going to be the intramolecular forces. So what real quickly would be an intermolecular force? Between two molecules, right? So it's going to be between all the water molecules, right? And not just the forces in between the molecule itself, right? So we talk about separate H2O molecules and carbon dioxide molecules in there. Okay, so for water, which is going to be stronger, the inter or the intra? Intra. Why intra?
There's more energy required to break the molecule apart.
It's covalent. And so this is going to be probably one of the first times they're starting to really deal with energy dealing with this. So they're probably going to kind of be tripped up by, well, why do we have 40 kilojoules there and why do we have 927? So we'll probably have to explain, or either Dr. Sparks or we will explain to them that that's the energy required for breaking up that molecule, right? So we noticed that in our H2O liquid, we only need 40.7 kilojoules in order to get it from a liquid to a gas phase, right? So that's just, so which force is that? Inter. And then our intra is when we're breaking it up from that gas phase and we're breaking it up into our hydrogen and our oxygen on there. Okay. And this will just kind of go back to the other activities that they did on the Friday after their exam when they did the tape. They put tape on their desk and they pulled it up, and one of them has a negative charge and one of them has a positive charge, and they were kind of showing how they either repel when they held it up to somebody else's that had the same one, or they could either kind of go together and be attractive forces on that. Okay, so it's just a nice little photo, kind of generally how we kind of think about our intermolecular forces with our gases, liquids, and then solids on there. Okay, so we'll kind of take a look about a little bit kind of going back to Coulomb's law, dealing with this whole entire concept of energy and the charges and then the radius between the molecules. Okay. Okay, so then we're kind of getting onto this whole entire idea of this electrostatic force, right? And so the whole entire concept that if we have opposite charges, they're going to attract one another. If we have similar charges, they're going to be opposing each other, right?
Yes.
Yes. That's what I want to hear. Okay, in covalent molecules, it's going to be kind of determined on their polarity involved with the reaction. Okay. So with this one, we're talking about having kind of this net dipole moment, and then we're going to be referring it, instead of just saying a net dipole, we're just going to be kind of calling it our dipole moment, right? So they went over a little bit with that of drawing their nets. I think they didn't do it as heavily as they just kind of drew it within the bond. So some of them might be a little confused on that, so they might need some help on that. Okay, so then we're kind of starting to get into this whole entire idea of dipole moments. And we have this whole entire idea that obviously the positives and the negatives are going to attract. Why are the positives and the negatives going to attract? Electrostatic, right? So it's going to want to kind of bring those ends together versus bringing the two positive ends together on there. Okay, so it even shows on here, it shows what would be attracting and then what would be repulsing. So these two are going to be repulsing, obviously, but these two are going to be attracting on there. Okay, so it's also going to depend on the distance and the dipole moment, which is something that we'll have to kind of go over with them a little bit. And then these are just some more diagrams about how they kind of set up. Sometimes they're set up very nice, kind of more in the lattice. Sometimes they're kind of scattered and all over the place on there. Okay. So what do we think about this question?
False.
False. Why do we think false?
Because there are plenty of examples of non-polar compounds.
That'll be the key one on there. So if somebody were to ask you, one of the students were to ask you, how do I know whether gases are non-polar or polar, what explanation would you give them?
How do you know if a gas is polar or non-polar?
Well, no, how do you know that not all non-polar compounds are gases?
I would tell them to think about diamond. Diamond's just all carbon, so it's definitely non-polar, and it's the hardest solid that we know.
So always try to give them that example, so then they're like, oh, okay, I think about it now. Okay, lovely job. Okay, so this is just kind of going back to this whole entire, on that Friday after the exam, they pour water and ethanol to the charged rod and just kind of see whether it attracted or repulsed it, right? So now they're just kind of trying to go over this whole entire idea of that. And then they're going to talk about the possibility of hexanes and carbon tetrachloride, how they're existing as liquids. And then let's go over real quickly that how is it possible for octane to have a higher boiling point than water? It's a larger molecule. And we'll get more into this on Friday's lecture and on the worksheet. But that's one thing that you always have to think about is you have to think about the size of the chain, right? Water's gonna be a much smaller molecule versus this whole entire kind of spread out octane chain that we're dealing with on there. Hydrogen bonding as well. That's gonna play a big role in it. Because you're gonna have a lot more hydrogens on your octane, obviously, than you are just a little water molecule, right? Okay. Pretty sure we're not going to get past this point in class just because there's a lot of slides on there. And then we'll start getting more into this whole entire idea of the induced dipole moment, which I'm pretty sure we'll be going over those on Friday. Okay, so did everybody go over their worksheet that we're going to be doing on the activity we're doing Friday in class? Okay, so let's go over that guy real quick. Okay. Okay. Very good. Okay. So does everybody feel confident on drawing the Lewis structures for these? Is there any particular one that nobody feels confident on in any of these guys? No? Okay. We're feeling good on? Okay. So we'll just briefly look at them just to make sure we're all on the same page. So we know that obviously our hexanes and octanes are going to be a lot larger of chains on there. Our ethanol is only going to have the one hydroxide group. When they're drawing the ethanol ethene diol, they're probably going to have a little bit harder of a time possibly realizing that this oxygen here is going to be connected to this carbon and then this oxygen will be connected to that carbon. So they may need some help on that. Carbon tetrachloride, I know we've done that one before in class, so they should be pretty confident. The hexane and the nonane, hexane and the octane, I'm sorry, they may have not gone over their prefixes just yet, so they may not realize hexane's going to be 6 and octane's going to be 8. They should be okay with it, but
I mean, it gives you the formula.
never mind. Ignore what I say. Okay, so I don't have a blank copy of this. And I don't put the answers up there. Okay, so when we're looking at their table on our previous page, right? And if you don't have it, just go ahead and share it with somebody. What's the correlation between the molecular weight and the boiling point, generally speaking?
As it goes up, boiling point goes up.
So we notice that trend that we kind of see as we're going throughout the table on there, right? Okay, so number 2. So what do we know about correlating the structures of the molecules and the boiling points? Do we notice anything that's different on some of the molecules that some of them have that some of the other ones don't?
Polar.
So remember polar, but why also are they polar too?
Because oxygen.
They have those hydroxide groups on there, right? And so what do we notice that if we have more hydroxide groups on there, does that change the boiling point?
Yeah.
Yes. Why?
Hydrogen bonding.
Hydrogen bonding.
More available.
It's all going to relate to that whole entire idea of the hydrogen bonding on there, right? So we talked about molecular weight. So obviously we know the molecular weight is also going to tend to tie into kind of size a lot of times, right? We noticed that octane chain is going to have a higher boiling point than the hexane versus the methane and whatnot on there. Okay? Let's see. Okay, so looking at number 5, we're talking about the y-axis and the x-axis. So what is the y-axis telling us? The boiling point. And then what about our x-axis? From what? Periodic table. Okay, so when we move within a period on our graph, what is it telling us about the boiling point? Yes, Michael?
It goes up.
You don't have to use Michael's little hand when you're explaining that to students. Okay.
I always talk my hands though.
I can see that. Okay, so what do we notice when we move within a group?
As you go down.
Say that again?
There's a general increase beyond that initial jump.
It's in a general increase, right? And we kind of noticed that period 2, and this is kind of going over question number 2. Period 2 doesn't really tend to follow that trend as much as everything else does, right? We kind of notice that we tend to see that trend a lot more with the period 3 and 4 and 5. Why do we think that we don't see that with period 2 as much?
It only has one valence shell.
It only has the one valence shell. So we're looking into this whole entire concept, not the carbons as heavily as we are like your nitrogens, oxygens, and fluorines too, right? Those are also extremely electronegative, so that's going to kind of play a little bit role within that as well. Okay? How are we feeling about the worksheet? Confident? You can explain it? Awesome. So we will be doing that in Friday in class. We'll obviously have more slides to go along with that. And then we're doing a small PLA activity today. Yes, very busy day.
Yeah, I'm like going across.
Okay. So what we're going to do is we're going to be talking about leadership styles today. So if you guys have a piece of paper, go ahead and pull it out. You can even split a piece of paper with somebody and have, it doesn't matter. This is only for your records. So this is not going to be viewed by anybody. And take a couple of minutes here and think about your leadership skills, kind of what do you do when interacting with the students, when leading groups and whatnot. So just take a few minutes and kind of jot some ideas down regarding that.
I'm sorry, we didn't hear that.
Yeah, I know.
Yeah.
Chit-chat. No, take a few minutes and write down kind of like what leadership skills you believe that you have in yourself.
In the context of the classroom.
In the context of the classroom, or just in general too. It doesn't have to be just within the PLA program, but just kind of what you kind of see in yourself on that. And then we're going to kind of go over that. Okay, does everybody have a couple things jotted down? No, you don't need a whole entire paragraph on yourself, Michael.
I was trying.
Okay, so what we're gonna do is we're gonna go over a little sheet that Jenny Smith has made up, and it's 10 very kind of general leadership styles and whatnot. And the idea behind this is go ahead, based on the skills that you wrote down, go ahead and see if you can find 2 of them that kind of apply to you. And then also, maybe you see these 2 apply to you, but maybe you see another one and you kind of want to have that one maybe for the future and whatnot, okay? And so the different type of styles we have on here. So we have the autocratic or the authoritarian. Typically do kind of an absolute power over his or her employees, telling them what to do. Typically team members have little or no say in the process. Then we have bureaucratic, where you're working pretty much by the book, making sure that nobody's kind of delineating from the kind of set goals and whatnot. You also have charismatic, lots of enthusiasm and energy, not necessarily as big on the team as they can be believing in themselves more. If the leader of the organization were to leave, sometimes it could be kind of seen that the organization will kind of start kind of taking a nosedive because that charismatic person isn't there anymore. Okay, then we have democratic or participative. Democratic ones, they make the final decisions, but they kind of let the people kind of help with the decision process as kind of what direction they're going to head with everything. They allow members to kind of feel as though they're in control of their own destiny, but not necessarily letting them actually be in control of their own destiny. There's also the laissez-faire, which in French is let it be. So it's this whole entire concept of kind of letting people do their own thing, very minimal assistance and support. This can sometimes kind of tend to be how a lot of companies will work, depending on what you're doing. In my previous work experiences, that's how we work, because we all kind of knew what we were doing, so you were just kind of left on your own to do a lot of things. It requires a lot less management time to be focused on you, and it's really good for places that are really busy, don't have time to focus on every single minor detail. Then we have task-oriented, very structured, uses lists, make sure everything gets done. The bad thing about this one sometimes is that the group welfare is not the main focus. So the main focus in that one is to get the project done, which is great and all, but then sometimes it's not taking into consideration personal needs on there. People are relationship-oriented, people that are focused on helping, kind of almost the opposite of the task-oriented one, right? More kind of worried about the interaction with the people and stuff. Sometimes the bad thing is doesn't necessarily always lead to getting the task done, though, if you're too concerned with that. So you've got to kind of find that balance sometimes between the task-oriented and the people-oriented. So the other couple ones we have, servant, which typically these people are not going to really be even recognized as leaders, because a lot of people aren't even going to know that they even are the leaders of a certain organization or whatnot. Let's see, transformational, very optimistic, good team motivators. They don't necessarily have to lead from the front, they can delegate, but also their enthusiasm can be infectious. And then situational leaders switch between different leadership styles depending on people, and kind of also just depending on the situation on there. So does anybody want to mention what they think they are out of these 10 ones? Michael?
Oh, y'all probably could just guess it. Charismatic and people relationship one.
Does everybody agree on that one?
Cool, thanks guys. I'm glad no one said autocrat. Like that's cool.
I'm pretty sure nobody would say you're autocrat. Not as far as that. Do it.
I'll just work situational,
So what about anybody else want to?
I'll go. I would probably say I'm situational, just because when certain situations come up, you have to handle it very differently. And like for something like this program versus if I play rugby, you have to kind of lead in different ways. If one
to be more charismatic in the other one. Anybody else? Armin?
I don't know. Like you can cut.
What do I think you are?
Yeah.
Ooh,
You didn't say that.
let's see. I don't know what skills you wrote down though. I'm gonna go with non-authoritarian on that one.
He seems laissez-faire.
Yeah,
I was gonna say laissez-faire.
That's a pretty fair estimate.
That's a pretty fair one. I would either go with I was gonna say servant or people in relationship oriented. Well, an ESP Armin just kind of does what I tell him to do, so based on my relationship with him. Anybody else? Kadiza?
I would say people oriented.
I would agree.
I would say, I guess my three is authoritarian, the people oriented, and then the situational. Because there's times that you have to be authoritarian for things to get done. Because I've noticed that in one of my other labs when I've had two other partners. And you have to like either tell them what to do or else it's not gonna happen or you have to do it. But at the same time, like you have to take into account like who you're dealing with. So there's your people oriented aspect, and then situational, like, that's completely different than in the classroom, where it's here it's more people oriented.
Right.
And you have to deal with a wide range of students.
Yeah, I know me personally, like I'm very situational because obviously when we're in this classroom, I tend to be very authoritarian because I have to be, right? But then once we actually get into the classroom setting, then I tend to kind of vary in the back. You know, I tend to more watch you guys, but I'm not as active as a role. And then sometimes when Sophie and I are discussing things, I'm the very laissez-faire one. I'm just like, Sophie, it'll be fine, it'll get done. She's the one that's kind of, she's freaking out about it, you know? So I know for me personally, I'm definitely situational because it just kind of depends on where I'm at, you know, as to whether I have to put on that more kind of authoritative role or do I kind of do this whole entire laissez-faire premises behind it. Is there any one of these that anybody would like to kind of try to start emulating? Ayo.
Why me?
You're right there.
Should I leave my people or relationship oriented? Maybe I'd like to try authoritarian once.
Just lay down the law.
Just once, you know,
See
like
how
show up
people
one day and be
react to it.
completely different, and people are like, who are you? The other side of AL.
The other side.
This is gonna be a bad documentary. Dictator leadership. Starts taking over the world. Anybody else? Nicole? I'm calling on you guys. You guys freak out every time.
Should probably be more relationship oriented.
That can definitely be a good thing because it definitely, especially when you're working on projects, that can definitely help a lot. Because obviously you take a very authoritative role, which sometimes you need to if you have people that are not working well together, but sometimes you don't want to necessarily take that role like right out of the gate working on a project because then they're like, oh, look at that person. You're just kind of control everything. Anybody else? Manny?
I'm definitely authoritarian. Definitely.
I think we all know that.
And if I'm not authoritarian, then I'm laissez-faire. Which is pretty much if I'm not controlled, then you should do it on your own.
What would you possibly like to emulate in the future?
Just more authoritarian.
So you're gonna take over the world with Ale.
Yep. Me and the other side of Ale.
Yeah, that's the remember that.
I have to wait until he grows an evil goatee. You got it. No, I should probably be a little more people/relationship oriented.
Okay. I don't think we have to worry about charismatic for most of you guys. So, don't forget about these things on the other side. I think most of us are somewhat transformational.
We have to be transformational in class.
You have to be, yeah.
Because
Yeah,
you are.
they're like, why are we doing this paper? It's like, come on, you're in this class, you paid for it, we want to help you learn.
definitely have to be transformational in class, because you also have to be, just be very optimistic with them, because a lot of them, especially if they aren't doing well in the class, then they're already kind of down on everything. You know, and a lot of them in that classroom are first-year college students, you know. So especially if they haven't done well on their first couple exams, they're freaking out. They're thinking their whole entire college career is going down the drain, you know. And so they need that optimism from you guys, like, hey, we know this is hard. We've been through it. Plenty of people have been through it. You'll survive. You'll get through it, type thing. So. Okay, so another PLA training done. Check. Okay, awesome. Well, I will see you guys in class.
So guys,
Still 14 minutes.
Yeah, actually, I was like, stop talking.
I was just wondering if we had a class.
No one believes you.
I walked up and I was like, okay, we need to stop. We need to start working. And she was like, yeah.
You're like, no, I just need you to run things.
Yeah.
And then I'll look it up. Authoritarian.
I get a lot of class, so you kind of keep an eye out where we're at.
Mechanisms. Oh, I don't listen at all.
Thought you were transitional?
Yeah.
You are.